Hello everyone, I'm Dr. Vidya Suresh Deshmukh, Associate Professor at the CSMSS Chhatrapati Shahu College of Engineering, Kanchanwadi, Chhatrapati Sambhajinagar. Today I'm going to present here the syllabus preparation of the basic calculus by NEP 2020, CBCS and OBE implementation for the STC program. Integrating the choice-based credit system with outcome-based education in the basic calculus curriculum ensure flexibility and learner-centered education while maintaining the academic quality. CBCS follows the student from the different stream to the choose relevant calculus module and the learn at their own place, encouraging interdisciplinary understanding. At the same time, OBE focuses on clearly defined course outcomes aligned with program outcomes by ensuring students gain practical skill in the problem solving analysis. So, the introduction of today's presentation is the framework for developing the basic calculus syllabus aligned with the National Education Policy 2020. We focus on implementing the choice-based credit system and outcome-based education to foster a deeper understanding and application of the mathematical concepts. The objective is to equip the student with essential analytical skills and prepare them for the advanced studies in the mathematics at its applications. So now here some objectives of the basic calculus. The objective of basic calculus is to enhance the application skill, introduce calculus fundamentals to boost students' application skills and prepare them for the higher analytical mathematics. Equip with the calculus tools. They provide students with the tool of the calculus to measure the various quantities like the curvature, torsion, and the point motion in the space. Third objective is to analyze the quantitative relationship. The student will analyze relationships between the quantities like the rate of change, area, volume, and curve properties. Last objective is the deepen analytical fundamentals. The further strengthen the fun foundational understanding of the analytical mathematics. So now here some prerequisite for the basic calculus. So the first prerequisite is the basic operations. Students should know the differentiation, integrations and limits. Also the algebraic concepts, partial fractions, binomial theorems like that. And third one is the geometry and vectors, the plane geometry, conics, basic vector algebra. The student should know that basic vector algebra. Here is we divide this syllabus into 4 units. Having this syllabus is having 2 credits. So the first unit is the advanced differentiation and its applications. In this unit, advanced differentiation and application, we include the hyperbolic functions, higher order derivatives, Leibniz rule, asymptote, curve tracing, Cartesian and polar curve tracing, L'Hospital rule, applications of business economics and life sciences. Similarly, in the second unit, the name of second unit is advanced integration techniques. In this unit, we include a reduction formula for the various trigonometric and logarithmic integrals, volume by slicing disk, washers and cylindrical cells. It is the application of integration and arc length of the surface area of the revolution. The unit third is on the conic and coordinate geometry. The sketching conics, reflection properties, rotation of axis, classifications using the discriminant polar equations of conics. In the fourth unit, the name of fourth unit is the vector calculus. We included the triple product, vector functions, limits, continuity, differentiations, integration of vector functions, tangent, normal, acceleration components like that. Now, here we use the teaching method according to the Bloom's taxonomy. For the mathematics, it is very difficult to teach a student in, in the easiest way. So, here we arrange some interactive sessions, real world case studies, problem solving sessions, and digital tool integrations. Our teaching methodologies for the basic calculus are designed to promote active learning and critical thinking aligned with the principle of the Bloom's taxonomy. We claim we aim to motivate beyond the route of memorization towards the higher order thinking skills. Now here is the assessment strategies and the COPO mapping. COPO means the course outcomes and program outcomes mapping is necessary. So assessment are structured to evaluate the student attainment of the course outcome COs and their contribution to the program outcome POs. With COPO mapping, ensure the curriculum effectivity develops relevant skills and competencies. So here the our first CO is strongly mapped with the PO1, and CO2 is a moderate correlation with the PO2. CO3 is the weak correlation with PO3, and after the PO4 we can't correlate the basic mathematics is can't correlate to any PO here. So for the assessment strategies, we are divided the assessment into the some sections, just like the formative and summative assessment, quiz and assignments, midterm and term examinations, project based learning, presentations, and viva also. Now, for the continuous assessment, we can take the assignments, quiz, class test for this, and that continuous assessment having 40% weightage. Mid semester is the theory exam, and in this theory exam, the student should able to solve the problems, and the weightage of that theory exam is 20%. Next, for the end semester, it is the comprehensive evaluation. Now, NEP 2020, CBSE and OBE alignment, how is it possible in the basic calculus syllabus? So, the NEP 2020 gives us the holistic and multidisciplinary education, promotes flexibility learning paths, critical thinking, and holistic approach to the education, focus on the skill development and interdisciplinary studies. CBCS student CBCS is the student-centric flexibility, offers student choice in the courses, promoting intellectual freedom and allowing them to pursue their interest, leading to the broader education. And the outcome-based education focuses on the measurable outcomes, clearly defines what students should know and be able to do upon the course completion, ensuring accountability and the continuous improvement in learning. Benefits of this integrated syllabus. So it enhances the employability. Graduate possesses skills directly application to the industry needs, improved learning outcomes, increase student engagement and global competitiveness. So here in this four benefits, the improved learning outcomes means the clear objectives leads to better student performance and retention. Increased student engagement, flexibility, and relevance boost the motivation in the participation of any academic activity. Global competitiveness is the preparedness of students to international academic and professional areas. Now the conclusion. So the basic calculus syllabus under NEP 2020 integrated with CBCS and OBE is designed to cultivate analytical rigor and the practical applications. This framework ensure a dynamic, student-centric and outcome-focused learning experience preparing the student for the future challenges. The recommended readings for this basic calculus are G.P. Thomas and R.L. Finney Calculus 9th edition, M.J. Strauss, G.L. Bradley, it is and K.J. Smith Calculus, and also for this and H. Anton. Also, the digital platform is also available on the NPTEL and SWAYAM MOOCs. Thank you so much for listening me.